Properties of limits, part 2. Our essential question for this lesson is, what happens to the limit of a quotient if the limit of the denominator is 0? We recall that for any polynomial, for example, if you have the polynomial f of x equal, say, x squared plus 2x plus 1, if you want to find the limit as x approaches, for example, 1 of f of x, you simply substitute x equal 1 in this polynomial. So it will be 1 squared plus 2 times 1 plus 1. That will be your limit, which is 4. Okay, now the quotient rule. What does the quotient rule state? If you have a quotient, let's say your function f of x is equal to some function p of x all over q of x, the quotient of two polynomials, then the limit as x approaches a of f of x is the same as the limit as x approaches, as x approaches a of p of x divided by the limit as x approaches a of q of x, if this limit exists. If limit as x approaches a of q of x exists. If the limit as x approaches a of q of x does not exist, then you have to simplify the quotient before you find the limit. Okay, let's do some examples. So we want to find the limit as x approaches negative 2 of this quotient here. This is the same as the limit as x approaches negative 2 of x cubed plus 2x squared minus 1 divided by the limit as x approaches negative 2 of 5 minus 3x. So it's a quotient here. And the numerator is a polynomial, so we simply substitute negative 2 in that polynomial. So it's negative 2 cubed plus 2 times negative 2 squared minus 1 divided by, the denominator is also a polynomial, so we simply substitute negative 2, 5 minus 3 times negative 2. That gives us negative 8 plus 8 minus 1 divided by 5 minus 6, negative 1. That gives us negative 1 over negative 1, which is 1. Okay. In some cases, the denominator, the limit of the denominator will be 0. For instance, if we substitute 1 here, this denominator will simply be 0. If we substitute 1, it will be 1 minus 1, and this denominator would be 0. But you will realize that if we draw the graph of this function, it's a straight line, and the limit as x approaches 1 should exist. It should be some value somewhere there. as x approaches 1. It will be some value there. So in this case, what do? We are going to simplify the polynomial before we find the limit. Or we will simplify the quotient before we find the limit, sorry. So this will be the same as the limit as x approaches 1. X squared minus 1 is the same as x minus 1 times x plus 1 divided by x minus 1. And now this will cancel with that to give us the limit as x approaches 1 of x plus 1. And that's a polynomial. We simply substitute 1, so it is 1 plus 1, which is 2. So the limit as x approaches 1 for that function is 2. I want to say a little bit what is the difference between this function and this function. What is the difference between the two? For this function, what you have is no, let's begin with this function. For this function here, we know it is a straight line, x plus 2. It's some straight line like that. That's the function x plus 2. But for this function here, it is also a straight line, but that straight line has a hole. It doesn't exist when x is equal to 1. So at 1 there is a hole, and then it continues. That's the difference between the two functions. Okay. Next, what's the limit as x approaches 0 of this function? This will just be the same as we simplify the numerator. We'll have limit as h approaches 0 of the numerator becomes 3 squared, which is 9, plus 6h plus h squared minus 9 divided by h. And this is the same as limit as h approaches 0 of 6h minus h squared over h. And the h now is the same as limit as h approaches 0 of h times 6 minus h divided by h. And the h in the denominator can now cancel with that h in the numerator to give us the limit as h approaches 0 of 6 minus h. As h approaches 0, this will approach 6. So it's equal to 6. Example 3. We want to find the limit as t approaches 0 of square root of t squared plus 9 minus 3 divided by t squared. This we can simplify in a way that will, the denominator will not be 0 also. This becomes the limit as t approaches 0 of t squared plus 9 square root minus 3 divided by t squared. But we can multiply this function by the conjugate of the numerator, square root of t squared plus 9 plus 3 and we divide by the same, square root of t squared plus 9 plus 3. Now the numerator will just give us t approaches 0. The numerator will just give us square root of t squared plus 9 squared minus 9, which is t squared plus 9 minus 9 divided by, the denominator is t squared times t squared plus 9 square root plus 3, which gives us the limit as t approaches 0 of t squared divided by t squared times square root of t squared plus 9 plus 3. Now the t squared can cancel out numerator and denominator to give us the limit as t approaches 0 of 1 all over square root of t squared plus 9 plus 3. Now you see that if t is equal to 0, the denominator is not 0 anymore. So that gives us 1 over, when t is 0, the denominator gives us 6. 1 over 6. So the exact value of that limit is 1 over 6. Okay. Please download the worksheet and solve it. Thank you.